Whew, my Stream Deck just blew up on me. I tried to hit the button and it shut down. So that was fun. Good morning, everybody. Thanks for joining. Good to have you here. We're going to do some IPv6 stuff today because the age-old conversation is still there where the world is running out of IP space, and we've heard it for decades. And NAT's always solved that, but the main problem is ICXs don't support NAT. So we need to find ways to navigate around that. And I know NAT's usually done in firewalls for the most part, but having the ability to get IPv6 up and running, and this is where I'll kind of pat ourselves on the back a little bit. We do a really good job of the IPv6 implementation. It's very clean. It's great. It works really well. I've heard from multiple people that they really like how our v6 implementation works, how it behaves, the behaviors that come out of it. We do support /126 and 127 masks on point-to-point links, so you don't have to use /64s for everything. It works great. We have really, really good overall usage of it. So we're going to do that. We're going to build it out. I'm going to do this. This is a really, 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 really big environment. Actually, I need the slide. Hold on. Really big environment. So I know that looks a little ugly, but I think you get the point. So we're going to focus on the data center out to just these corp sites because they're point-to-point links. For the most part, everything is built. So v4 is up and running. Everything's IP'd. OSPF is running. I didn't want to have to go through that entire headache and bore everybody to death, but we'll get that piece up and running. We'll go through and we'll do some route advertisement suppression where it needs to be and really just make it work. So I'm also going to go through some standards and best practices that I would recommend to anybody doing this, things that you can do with the point-to-point links. These are great switches. They're great routers. They do a really good job with routing. And they're extremely in-depth and versatile. So we'll kind of go through some of that stuff. I know that, it's a pizza box and it has layer 2, layer 3. So there's different things that we can do in there to really ensure that we're not going to run into, any kind of issues or headaches down the road. So let's build it out. Let's do it correctly. And make sure that everything's working and nice and fancy. I am having weird issues with my Stream Deck, so if anything lags or blows up, that's why. So, but this is kind of what we're going to do. So I'm going to take, first thing I'm going to do with this is I'm going to take our links that we have that are point-to-point links, and I'm going to break those out into separate VLANs. And we're going to do this independently. So if you look at this, you can see that in my data center ag router, I have these links here, they're all point-to-points. Well, all of these links right now are members of VLAN 1. Well, I don't want them in the default VLAN. So I'm going to take and break it out, and I'm going to create individual VLANs for each one of them and untag those links in there so that there's never any issue of any layer 2 headaches happening. It's just a safety mechanism. And then it's less we have to worry about as the network just pushes along and moves and runs for the rest of its life, right? Yeah, so we're going to break those out. I'm going to do it simple, clean, and smooth. And then once we've got that done, it won't affect anything routing-wise because I think these are route-only interfaces. Yeah, I'm already running route-only on them, so it's not forwarding frames on them anyway. So we've got it pretty clean. Another thing, too, is because depending on the device type and the model, I do turn inline power off on point-to-point links just because I'm weird that way. I guess there's not really any necessary need to do that. But it's helpful, and it makes it to where now we don't have to worry about it. So no power on it. Everything that we're touching is probably in OSPF area 0 because it's all touching the border. Yeah, and then I know if you joined last week, you heard some of this, but the way that we handle IP space, or I do, I'm using 172.1.6 space for the point-to-point links. Everything else that's done is all on 10 space, but I can still marry that stuff up. So the data center's links are 10.254. So I use 254 as like the identifier for the data center. 240 is the identifier for corporate site 1. 241 is the identifier for corporate site 2, and I think 245 is the call center. So it just cues right away that I see and I know where that link is going. With the IPv6 space, we're going to do the same thing. So we're going to lay that IP space on top of it and marry it up and make it look the same way. And I'll show you exactly how we do that. And it keeps it super simple, clean, and organized. So if I have an IPv4 address, I'm going to make it match with the v6 address so that there's no confusion. And my hosts that are running v6 are already IP'd anyways, so I don't even have to worry about it. So, but first things first, let's make some VLANs in here and get everything split out so that we don't have to worry about it. So I'm going to do this way. I've got these 5 interfaces that we're going to place in separate VLANs. So I'm just going to use the interface numbering to create that VLAN and put it in there. So here, for example, config T VLAN 1118, name, point to point, 1x1x18. And then we'll untag E 1x1x18, and it's in there. So, boom, nice and clean, right? Now we need to do the same thing. And I know this looks like a headache, and it is a little bit more work than you were really wanting to sign up for at first, but it's a good practice. So, VLAN 1119, name, point to point, E 1x1x19, and then we'll untag it. And as a shout out to RUCKUS TAC, this is a conversation that I've had with them. If you're ever on a call with them, talking to them about anything, they will also recommend that you do something like this. So shout out to Vu, because he really kind of sat down and had the conversation with me about it and walked through it and made sense. So VLAN 1120. And these, I'm just using these VLAN numbers. I'm pulling them out of thin air. There's nothing that says it has to be done this way. Because I know in your environment, you probably have a lot of VLANs and you have a lot of traffic. And so you just need to find VLAN numbers that you can use as a container for those point-to-point interfaces and be done with it. E 1x1x20. Oops. Untag E1120. And then VLAN 1121. (1121). And then we also had 24, right? I have to keep going back up to this. Yep. VLAN 1124 name. And then right mim it. So I don't blow it up. That's always bad. Hey, making tech sense. Good morning. How are you? Thanks for joining. Okay, so we have that done. I'm actually going to, this is, I don't know if it's bugging you, but I'm going to turn console logging off because just keep a little cleaner. If anything blows up, I'm sure we'll know pretty quick. So, okay, now let's do the same thing over here. Oops. Yeah, we have the same interfaces, so config T. Oops. I actually have this in a notepad file. I could copy it, but it's more fun if you guys have to sit here and watch me struggle. So, VLAN 1119. Point to point E 1 by 20. And then we had 21. One 21. We had 24 too, right? Yep. 1124 name 1124. And then we'll untag it. Boom, done. Now, you do something on one side, you have to do it on the other. Morning, Jose. Thanks for joining. So, we can do this a number of ways, right? We can look at our FTP neighbors and it'll tell me what's where. So I have to now also go to all these other devices. The edge routers I don't have to necessarily touch. In the diagram I showed you earlier, this one, there may be some nuances with this because I have a new laptop. I don't have Visio installed yet, so I couldn't correct it. But there's some extra devices inside of the data center. There's some edge devices in there. But they're not really going to come into play because we're not going to, that piece would be for the BGP piece we would lay on later, going out to remote sites. So I'll update the drawing when we get to that point, but for right now, what we're doing and what our interest is, this is all accurate. This is really all we care about. So, and plus the edge devices, those are, I think traffic to those is tagged going up to it, and there's a lag built. So we just route it over the VEs and it's fine. And then the connections going down to the distribution switches, those are all layer 2 switched as well. So we don't have to do anything VLAN wise to segment those links. We just need to do it on the links that are going up to the corp sites. And I think based on time that we're going to have, I'll probably just focus on the corporate sites, mainly because this is a ton of work and a ton of info. So I don't want to go into a 3-hour long session where we're trying to get all this stuff sorted out. You know what I mean? So let's focus on the corporate sites now. So we'll go to Corp Office 1. And we'll get in the distros there, and I've got to change this real quick so you can see it. If the font's too big, too small, anything, let me know. I'll update it or fix it. So, okay, show IP interface. We have 2 links, and it's both the point-to-point links going to the data center. So this one will be a little bit easier. So config T, VLAN 1118, name. Excuse me. And now, oh, you're still seeing the diagram. I'm sorry. Just sitting here complaining about my Stream Deck not working, and then I realized that it works really well if you push the buttons. So, you know, I always got to have that reminder in there. Okay, that one's done. Now, oh, let me fix this one. I wish I could do this globally for all the connections, and I haven't found a way to do it, so I have to bear. Oh, that one's already set. Cool. Bear with me. Same thing, 2 links, so config T, VLAN 1118, name. Okie dokie, now we'll go to the other one. I'll do this first. This one might already be done. Nope. Nice try. That one, and that one. That should be the same way. It is. So config T, VLAN 1118, name. Oh, really? Oh, I already did this. Yeah, but it's wrong. Ugh. Alright. So, obviously you can see that I like airplanes because I named something 787. So I'm going to take 18 out of that VLAN and put it in the other one, and then that way they're separated out. I just dumped these configs back in this morning, and I have a script that does it, and sometimes the development configs don't get pushed back to my server, so that's why this one's a little off. But my heart was in the right place. I tried. So VLAN. Ah. Okay, there we go. Now let's get the other one done. Let's see if I did the same thing here. I may have. I did. Config T, VLAN 787. Hey, you guys want to see something cool? I think it's this switch. Watch this. No, maybe it's this one. Oh, really? So this one was spitting out a PoE bitmap error. I think it's got a faulty PoE module in it. I'm pretty sure it was this one. But I dumped a config back in and reloaded it, and apparently it's fine now, because it was showing me that, oh yeah, hardware version unknown. So this thing's still pretty broken. It's just not complaining about it right now. But if you see that, it's bricked, so we have to RMA it. So this is the one thing you always have to kind of look for, is the hardware version unknown. That's when you know you have a problem, and we have a problem. So I've already let the lab team know. I'm just waiting on them to replace it. So I probably won't do a whole lot in this site's access switches, just because it won't do me any good. So, but yeah, you see that. That's what's happening. So, always fun stuff. Yep, RMA. So, okay. We have that done. I'm excited. This is fun. Now we're going to do some V6. What I'm going to do, if you were here last week, we did MCT. This thing probably got loaded in here. Yep. So I'm going to have to break that, because my DHCP server won't work with the way this is right now, because MCT won't pass or route the IPv6 traffic. So I'll have to pull the client switch out of the MCT cluster, and then I'll be able to just, as a test, ping the DHCP server. So what I want to show you is, I'm going to jump into this thing real quick. Oops, I need to make this bigger. Display. There we go. Okay, this is how I make V6 really, really simple. Okay, this guy's IP address is 10.254.20.50. 254 data center, 20 it's VLAN 20, and then 50 because I felt like it. But with the INET addressing, or the V6 addressing, so we use 2001 DB8, and it's reserve space. It's for education stuff. I know that our corporate network internally does route IPv6, so I wanted to make sure that I didn't end up laying anything on top of it that could possibly leak and cause a problem. So we just stuck with the reserve space, and it's reserved for education. But it works fine for us because it's not being routed anywhere. And it works fine. But as you can tell, what I'm doing is 2001 DB8, and then I use the site ID and the VLAN number, and then I just use the rest of it as the V4 address as it is. So I can make that translation in my head really, really quick and easy. And this is obviously a /64, so it makes it super simple, and it makes it just lay right on top of it the same way. Where you get stuck in this is, and I'm a cheater, man, I'll grab a V6 subnet calculator all day long and use that because I can barely count to 5. So when you're dealing with address spacing that is this large, I encourage everybody, go use a calculator because it makes it easy. Because with our point-to-point links, one of it might be, on one side it would be :8, and the other side it might be :A, just to make sure that you keep those inside that boundary. So what I'm going to do, I already did this, but in the interfaces, I'm going to lay it right on top of it. So turning on V6 in these guys is really easy. I think it's unicast, right? IPv6 unicast routing. V6 is turned on in the box. All it takes. Doesn't require a reload. We don't have to carve out any system pieces of it. We don't have to mess with TCAM. You just turn it on and it's on. Done. Just like that. Okay. Now I can actually put V6 addressing on the interfaces themselves. So we have to do two things. We have to not only address the interfaces in the device, but we also have to turn on V6 OSPF. And that's really easy too. It's just IPv6 router OSPF. So I'll do this IPv6 router OSPF, and then I'll just do area 0. Don't need to make it different, right? And then show in the show run interface E1118. Okay, that's our interface now. I'm going to go into it, and I'm going to use the exact same structure and model for the addressing. So I'm going to do IPv6 address DB8 172 240 172:16:240 : this is 1, right? 1. Yep. Just like that. And I'm using a /127. It's the same thing as a /31 in the IPv4 world, right? It's a point-to-point link. I don't need a network ID. I don't need a broadcast. And it's V6. It doesn't do that anyway, right? And then IPv6 OSPF area 0. IPv6 OSPF active. IPv6 OSPF network point-to-point. And then IPv6 ND suppress RA. So why do we need to suppress RAs? V6 doesn't ARP, so we don't have a way to find out who's who on a segment. But V6 will use router advertisements, neighbor discovery, neighbor solicitation, things like that. And that's how hosts find their routers. That's how they get around in the world. Well, on point-to-point links, we don't ever want to have the ability of a host attaching to it, and then all of a sudden it gets V6 addressed and it's ready to go, right? This is just strictly routing point-to-point. That's it. We don't want any host behind it, online touching it, anything. So we're just going to leave it. We're going to suppress all the route advertisements because we don't need it. The routers are going to be told, here's your V6 address, here's your V6 address. You guys can talk to each other. Leave it at that. Then we're done. Okay. Now what I want to do to turn this thing up is I want to go into this guy right here. I want to see DCAG1 1118. So I want to actually turn this guy up and make sure that our link comes up and that our OSPF adjacency forms. Because we're formed with V4, right? So IPv6 unicast, IPv6 router OSPF, area 0, show run E. Can I do this from here? Nope. Okay. IPv6 address 2001 DB8 172 240 240 colon. Oops, hold on. Oh, I need to make that other side of 126. Hang on a second. I don't want to have to fight with that. There. IPv6 OSPF area 0. IPv6 OSPF active. IPv6 OSPF network point to point. IPv6 indie suppress RA. Done. I wish you were here to give me a high five, because it came up. Now, there we go. We have a route. I didn't. I mean, I could. I just have to start at 0 and then go to 1. So, full disclosure, we had a minor issue with some of the prefix masks in v6. So, 126s are now supported. They weren't previously. I'm a little hesitant to go into a /127 because I don't know if there's an issue with that or not. I'm assuming there's not. I think engineering has resolved all of it. But we can. Yeah, exactly. Then I would want to change all the v4 addressing. And since I'm using /30s from a v4 perspective, I think the 126 is fine from that perspective. So yeah, let me pull a calculator up here real quick because I want to make sure. I can share this. Where is... There we go. So if I do this as a 1... Whoa. Oh my goodness. I need copy and paste. This is a lot of 2001 blah blah blahs. Yep, it goes 0 to 1. So I mean, we can do it however, and that's fine. So. Okay, I think I have my head screwed on straight. So I'm just looking at it from the standpoint of let's take a step back and we'll look at a /126. Now we end up 0 through 3, and there's 4 usable addresses in there. Should we probably use a /127 on the links? Yes. Should you also use a /31? In my opinion, if it helps preserve your IP space that you have, yeah. Do I have IP address problems in this environment? No. I have unlimited IPs that I can use for the most part, right? Whether it's v4 or v6. So I think we'll just keep it at the 126. That way it kind of falls within that same boundary. Marries up and matches. And we don't have to overthink it, right? So we'll just keep it that way and see how it works out. All right, let's go back into this guy here. So we have that link up. Now let's get the rest of them up. So now let's do 19. So back into the data center ags. So we're back in the link going to the other corp sites. And I'm just going to straight IP them and go through it. And we'll make it work. So, all right, show run interface E1119. Ugh. 240, 126. That's not right. I can't do 9. Hang on a second. I have to use my brain. It's got to be A. See, this is where you get screwed up. So no matter how hard you want to sit down and make your IP space marry up to what you're using on the v4 side, you can't always do that. So 9 doesn't exist. v6 addressing goes from 0 to 8 and then A to, I think, F. So you have to make that break. And so, yeah, I mean, Brian, to your point, you would want to change all your addressing to match it, but then you run into this scenario and you realize you can't, because I can't use 9, right? So I got to use A for alpha. Oh. Huh. There we go. Yep, I know. I was like, hey, that's... I mean, I'm glad I caught it, but yeah. Network range. Actually, hold on. I'm incorrect. You can use 9. You go 0 through 9 and then A through F. So I can use 9. It just means the other side will be A. So... there we go. Whew, too many interfaces, too many numbers, too many things going on. Well, I'm glad it happens to all of us, so I don't feel as silly anymore. But yeah, this gets pretty involved. So 19. Okay, so IPv6 OSPF area 0 active. Good. I'm glad everybody can enjoy my pain and suffering because you're familiar with it on your own. Let's press RA and then I think we're good there. Okay, cool. So end show run interface E1120. Okay, so this is 241.1. So we're gonna do config T. Look, I'm in the interface config level. I did it. Hey, you too, making Texans. Thanks. Looking forward to it. And we'll be back tonight at 6:32. So all of the fun and enjoyment that I'm having right now that you'll get to tease me and make fun of me for, you can do it twice in one day. So it's awesome. DB8, 172, 241. 1. IPv6. Alright, I'm cheating. You can make fun of me all you want, but I'm gonna cheat. Don't tell anybody. Copy and paste is your friend. Alright, we got that going. 1121. .241, 172, 16, 241, 9/126. Cheating again. Show run interface E1124. Oops. Oh, that's the call center. We're not going to configure the call center, so I'm just going to leave it. And it's fine. We can overlay this. So one thing I failed to mention earlier, if you configure IPv6 and you start putting this stuff together, you have v4 running and v6, because I don't think anybody is strictly v6 right now. You're what we call dual stacked. And when you're dual stacked, your traffic will prefer IPv6 over v4. So great example is Facebook. Facebook has v6 running entirely in their infrastructure. So if you're running v6 in your network, and you browse to Facebook, you will be using the V6 infrastructure. It will only turn around and prefer V4 if V6 doesn't exist for it. So just keep that in mind so that when you sit down and have to start troubleshooting something or dig into something, that's what's going on with it is, oh no, I can't get to it because there's an issue with V6. So just keep that in mind, okay? All right, we're gonna right mem that. Now let's go do the other one. Show run NRZ 1118. Okay. Oops, I almost did it again. IPv6 address. DB8, 172, 241, 172, 16, 241.5. Whew. Oh, I can't do that because tell me what I can do, I'll make you do it. Okay. Address 1 DB8 2 241 172 16 241. Okay, so 13 doesn't exist, right? So let's find what 13 would be. So 9, 10, 11, 12, 13, it would be D, like Delta. There we go. Okay. Awesome. Show run. DB8 240 whoops. Okay. IPv6 address 2001 DB8 240 colon 172.162.40 D slash 126. Show run interface E1124 was the other one. Yep. Oh, and we're not going to do the call center. Okay. Up. Okay, we're good to go. This is the easy part right now. We haven't even gotten into the VLANs yet. So, all right, let's get our corp sites done. So, look good there. Show run interface E1119. Config T. IPv. Oh, interface. See, I'm so excited to configure it. 2001 DB8 172 240 6/126. Whew. Okay. Cool, our point-to-points are there. Okay, good to go. They're up and up. So one thing to keep in mind too is the router IDs. The router ID is going to get pulled from the V4 version of it, and I mean that's fine. It's just a nuanced thing where I wasn't expecting it the first time I configured it. I thought I would end up with a V6 router ID, but it just pulls the V4 router ID. And obviously we're not going to see a DR or BDR because we're point to point, so those won't exist either. But they're there and they're up. And we can see our prefixes that we've configured are in the routing table. They're there. I should be able to ping from one side of this link to the other. In fact, This guy goes to, let's see, Ag 1. So let's try it. Let's see if I'm full of it or not. It's ping IPv6. Ugh. Some reason this doesn't work, and I don't know why. I wonder if this is yet to be resolved in this version. So this is the issue that was seen. So I'm not necessarily worried about this because I know that my OSPF adjacencies are up. The links are up. I can't ping across them because I think it's this version of software that we had an issue with v6/126 prefixes and you couldn't ping end to end on the link. But everything would form. Adjacency would come up. Traffic will flow. It's just that ICMP message going back and forth across that link. It gets dropped somewhere. I'm confident that this is fine. It's okay. It's working. It's just the ping across the links that don't work. So what I'll probably have to do is throw an upgrade at these before tonight's session just to make sure that we can verify that. I'm not super worried about it right now. So I know it should ping, it should function, but this is a defect in this version. So that's the only defect though. It's just the ICMP message is ignored for whatever reason. So okay, so that guy's done, that guy's done, that guy's done. Let's get this guy done. Show run interface E1118. Address 8.172 240 10. So 9 alpha. Phew. Oh, I lost my copy. That's all right. Exity. IPv6 router OSPF area 0. Oh. Oops. Yeah, Jose, I think you're right. And this is running Bravo, so it's 8090B. So I'll just pull release notes tonight and make sure. I know I remember reading it because I had been pestering. I know I'd pestered you guys too, but I was pestering engineering about what version they were going to resolve it in. And I saw the release notes when they did. And I think you're right. I think it's 90F. So, okay. All right. Fig T. DB8 240 14 9. Oh my gosh. Like mental gymnastics over here trying to figure this out. 9 10 11 12 13 14. E for echo. Yeehaw. Okay. Loading. Full. Yes. Okay. This corporate site is done. So what I'm going to do is I'm going to finish the other 4 links, get both ends of it up, and then we'll start to work through the VLANs and get those built because that's a little bit more involved. So show run interface E1118. Interesting. There's already an address on there. I'll have to take it off. So, teaching moment. 2001 DB8 172 241 double colons. That means that everything between those 2 colons are zeros. You probably already knew that, but I'm trying to be more specific with my address. I'm probably making it more difficult than I need to, but that would work as well. I'm just too particular with this kind of thing, so I would rather do it my way, because I like my way better. And that was my way, I just don't agree with it anymore. So DB8 241 172 16 241. The only thing that worries me is I don't know. I want to look and see. Okay. I didn't know if IPv6 unicast was turned on or not, so I'll just turn it on again to make sure and be safe. Yeah, that looks better. Okay. Show run interface E. Yeah, I'm gonna have to do the same thing here, so. No. Six? Did I do that right? I'm getting lost in my own thoughts here. That's scary. Okay. Let's just check it real quick and make sure. Looks fancy to me. What do you guys think? Good to go? Good to go. All right. That side's done. So let's get this side done. Let's config T, IPv6 unicast, IPv6 router, OSPF, area 0, 1118. Ah, I did the same thing over here. Darn it. Interface E, 118. No. A. Take this one out. And then we'll put the right one in. I guess I could probably just copy this and edit it instead of making my life more difficult than it needs to be, huh? E for echo for 14, is that correct? 10, 11, 12, 13, 14. Yeah, it is. Hey, that proves I could count when I did this. Copy this. Oh, duh. Okay, there we go. Write it. Write it. I'm happy. Show IPv6 OSPF neighbor. Look at that. Awesome. So, oh, this is funny. This site already has v6 built on the VLANs. So I guess the config that got pulled into it had all of this, and that's fine. Can show you what this looks like. So I basically have two VLANs created in here that are normal, I guess. I have 10, which is just the data VLAN for hosts, and then I have a voice VLAN. And this one's already been configured, which doesn't break my heart, so we can actually look at it and see what's configured here. But here it is. So I'm actually using v6 Verpi. I don't know if it's 100% necessary, but it's there and it exists. So I'm okay with it. But you can see that we have a v6 address here, and I'm using a pretty large prefix on it, right? We're using a /64. I have it trimmed down to where it's 2001 DB8 241 and then A, because that would be 10, right? So it still matches the actual addressing scheme that we have. And then obviously this is our DHCP server. So the main thing about this is the IPv6 neighbor discovery managed config flag. We can allow these guys to, all of our hosts can automatically grab an IPv6 address off of the router segment. It doesn't need a DHCP server. I have a DHCP server configured, so we use it, and I actually prefer it to use those. It won't work right now, because if I try to ping it, MCT has got this guy tripped up, so I'm not going to be able to get to it. But I know that, so I'm okay with it, right? But yeah, see, we can't get to it. So host can't grab addresses right now anyways. But if I look at the routing table, that's the other reason why it can't see it. It doesn't have a route for it either. And reason being, we haven't configured any of our VE interfaces in the data center to actually route that subnet. So I think what we'll do is let's jump into the data center distro switches, which I have one of them up, it looks like. Yep, this one here. And we've got to break this MCT piece. So if you've been through, this is a class that we use, and it's mainly been delivered internally. But if you've been through this, I usually sit down and say, okay, you have to find a way to break this MCT client out with as little impact as possible. So I want everybody to sit down, put their thinking cap on, and say, all right, how can we do this so that the impact is minimal? I'm not going to do that because A, I'm in a live session right now, and B, because it will take a really long time. So I'm just going to maintenance window it right now, break it, pull it out, get the VLANs I need tagged down to it, and be done with it. So first thing I'm going to do is I'm just going to bust the lag on this guy. Where is it? Yep. Okay, so those get shut down. That's going to change my tagging. 13 and 14 are tagged that way. That's fine. We can enable those. Spanning trees running. We're fine. Okay, so let me get into this guy. So we rip the cluster out, and I need to rip the lag out. Okay. Trying to think. Enable that. VLAN time. So 20 and 51 is what we have down there. Yep. So. Ooh, wait. Whoa, whoa, whoa. Hang on. I need to see this before I do it. Now I need to get spanning tree configured in 20 and 51, which is pretty simple, obviously. So config T, VLAN 20, span 8, 20. This is his master. So we're going to make him the root bridge for that VLAN. So span 8, priority 1024. What am I missing? I don't think anything. Oh, yeah, yeah. I need to do this for 51, too. Whew, that scared me. Oh, boy. Did I just blow this thing up? I might have. 2048, he's going to be the backup. Tag lag one like 30, 122. Okay, I'm happy with that too. So show span 8 VLAN 20. Oh wait. Okay, looks good. Let's fix the other one real quick. I want to go fast, all the way to the bottom. Cluster DC MCT1. No. Client access 2. Okay, now let's get VLAN 20 and 51 going. VLAN 20, span 8. Priority 2048, because the other side is the root bridge. VLAN 51, span 8. Span 8, priority 1024, because he's going to be the root bridge. So let's do a show 8 VLAN 20 and just make sure we have root ports going across, which we do. We're the root bridge. We look good. Okay, I'm happy. Everything in the access switch should be tagged correctly as well, which it is 1314. So show span 8, or wait, show 8 VLAN 20. Cool. Root port. We're discarding on the other port going up, so we don't have a loop. So we look good. Everything's set. I'm happy. Cool. Now, because I cheated earlier, I'm going to cheat again. I'm going to dump my VE config in there if I have it, which I don't. Oh, I don't have it. Boo-hoo. Oh, wait. I'm on the wrong device. Hold on. So mainly I'm worried about 20 right now. I just want to get connectivity to the DHCP server. That's what I'm worried about right now. So, oops. Dist 1. Hang on 1 second for me. Sorry, I have too much going on today. Yeah. Let me see what this guy looks like. VE20. Okay, that's what our VE looks like. I'm going to go ahead and just jam this entire config in here, starting at V6. So... this is 1 and 1. Oh, crap. I can't do that yet. IPv6 unicast. IPv6 router OSPF. V20. Now I can copy and paste that stuff. What? Why isn't it taking that? Oh, you're right. Thank you, Brian. But my question is, why isn't it IPv6 unicast? Interface V20. Let me just try and dump the address in and see if it'll take it. That's really strange. What? What? I'm running router code. Why on earth are you not taking a V6 address? Do I have this thing? 20. I think I know why. It's still tagged over the ICL. Yeah, because show cluster DC MCT1. Yep. member VLAN range, so I've got to find, I have to untag it off of that lag or the ICL and throw it onto the other link, which I think is 15 or 16. One of these is a routed link. Let me find it real quick. It's probably tagged in VLAN 4. Yep, 16. So what we're gonna do, whoops, VLAN 20, no tag, lag 1, tag E. That's just a routed link, that should be fine. Okay. I need to do the same thing over here now. So config T, VLAN 20 and 51. We'll do a range. No tag, lag 1. Whoa, come on now. Alrighty, now I feel like VE20. Let's see if I was right. Bow. I'll take a bow. Thank you. Thank you very much. Thank you. Oh, you're too kind. Thank you. All right, and I'll get my V6 priority in here too. Oh, IPv6. Can't turn on VRP if you don't have it enabled in the router. Okie dokie. Yeah, I agree. Thumbs up. Cool. Okay. That's good. Let's get this other guy going. So show run interface VE20. And again, I'm going to cheat and I'm going to pull the config out of my config note and save a little bit of time here. So first things first, config T, IPv6 unicast routing, IPv6 router OSPF, area 0, IPv6 router VRP, VE20, jackpot. Now let's do V6, VRP. Okay. So now what I really want to see is this guy, show IPv6 route. I want to see if these routes are in there and being announced yet. Oh, and it's not, because now we need to get so let me go back to this. We need, oh, hold on. Come on, pen. We need some V6 in there. So in the routed link that we use, it's all done with VE4. That's the routed VLAN that I use within the data center. So I'm going to basically take in all 4 data center routers or devices. I'm going to build out the V4 addressing on VLAN 4 so that we can route between them. And then it'll be taken care of. Right now, we just don't have a way to route any of that stuff back and forth. So that config is really super simple, easy. Go to dist2, show, run, interface VE, 4. Done. Slam it in OSPF. Good to go. Happy, right? Distro 1, I'm going to do the same thing, but I don't, ooh, that's not in that config, so I'm going to have to do this by hand. So show, run, interface v4. How did I do this over here? Let me double check. 2001 DB8 254.4. Okay. Oops. This guy. Interface v4. Just like that. It's beautiful. Beautimous. Let me get this other one. I gotta get the V6 OSPF stuff out of it. Okay, that's good. Now we need to do the same thing in the ag routers. Show run interface VE4. Hey, wait a second. 3, 2. Okay, I'm good. Interface VE4, IPv6 address 2001, DB8, 254, 4, ::4. Everybody understand what that's doing? It's just double colons is just basically saying omit all the zeros in there. I don't need to type the whole thing out. It's fine. Okay, so we're good there. Now let's get ag2 going. Show run interface VE4. IPv6 address 2001 DB8 254 4 5. And then I'll dump the OSPF stuff in there. Now we should be able to go into this guy and see if we have routes. Ooh, and we do. They're there. So the main question is now, can we ping our DHCP server? So ping 2000. Oops. IPv6 2001 DB8 254:20 10. Of course. Okay, I can ping it from there. This guy doesn't seem to want to ping it. Oh boy, I don't know. I don't know if this thing is even powered on. I probably powered them all off because of power savings. So I think I can say happily and confidently that we at least have V6 up and running. I obviously have some back-end work to do because I've got to go in and get the VMs turned on so that they can pull a V6 address. But the hosts are there. They're live. Excuse me. Ping 6. Yeah, ping 2001 DB8. What was the address on this guy? We have VE210. I want to ping this guy right here from the host. Okay, I can ping the VE in that corporate site from the DHCP server via IPv6, so I'm calling this a win. We did it. So, yeah, that's awesome. Windows 7 are the VMs that I have installed in there right now. I'll try to get some Windows 10 VMs going today. I have a couple. Windows 10 handles IPv6 way better than 7 did. 7 was killing me. I had to do all kinds of crazy things to the NICs on them. So if you have an environment at work or somewhere and you're dealing with that, just know that it's challenged with Windows 7. But Windows 10, it works great. So during tonight's session, I'll have a Windows 10 VM up and we'll actually watch it pull an address from the DHCP server, and then we'll just be able to tail the log to are you kidding me? That's my server. How do I not have permission? There we go. But it's logging everything to it. So we'll be able to watch the logs. We'll see the addresses, go out and get to it. And yeah, it'll be a lot of fun. So I'll get that thing going tonight. I've just been a little scrambly busy this week. So we'll do that tonight. 6:30 Mountain. Hope to see you back here. And as always, thank you for joining. It's been great. Brian, thank you so much for your help. I couldn't do this without you. So yeah, if you have questions, suggestions, things you want to see, don't forget you can send us an email. It's ruckuslive@comscope.com. We take all of your suggestions very seriously, and we will apply those to this. But yeah, this has been a blast. So thanks everybody. Come back tonight and take care.